Okay, here's a problem from homework number 9. It says the following data summarizes results from 993 pedestrian deaths that were caused by accidents. Pedestrians are people who are walking in crosswalks. If one of the pedestrian deaths is randomly selected, find the probability that the pedestrian was intoxicated or the driver was intoxicated. So taking a quick look at our table here, we can see that our pedestrians are broken up into two groups. There are the intoxicated pedestrians and the not intoxicated, in other words, drunk. And if we add up these numbers, there are a total of, and I've got my calculator here, which we can look at, 56 plus 274 is equal to 330. So we have 330 intoxicated pedestrians, and we have 90 plus 573, 633 sober or not intoxicated pedestrians, 663. Okay, all these people unfortunately died in some sort of car crash. Now over here we have our driver, and we're looking at them where the drivers were intoxicated or not intoxicated. And in this case, there were 56 plus 90, 146 intoxicated drivers causing accidents or involved in an accident. And lastly, the final group, 274 plus the 573 seems to be our biggest group, 847 not intoxicated, which is good. Shows that most deaths still are caused by other causes. All right, but we need to find out the probability that either the pedestrian was intoxicated or the driver was intoxicated. And we write this in the form of a union. That means or. Now we have a formula for this, and I'm just going to go ahead and write it down. It's going to be the probability that the pedestrian was intoxicated plus the probability that the driver was intoxicated. But because those people get counted twice, we have to subtract off the doubling up of the pedestrian who were intoxicated and those accidents where the pedestrian was intoxicated and the driver was intoxicated, because we'll see in a minute how those people get counted double. Okay, and so this means this symbol here is our and. They were both, the accidents where both of them were intoxicated. But we're asked to find out what's the probability that either one or the other was intoxicated. So it's going to be more people. All right, so the probability that the pedestrian is intoxicated, that looks like we have a possible 330 people. Out of how many people can we choose from? Well, that goes back up to the total here, 993 accidents that we looked at where pedestrians were killed, plus, all right, where are our intoxicated drivers? They're these guys right here, the 146 out of the 993. And then we're going to subtract off those people that were counted twice. And that's the important thing not to forget. Who is both, where both are intoxicated? We're looking at these 56 people right here. You can see this is where the pedestrians are intoxicated and the drivers are intoxicated. So it's going to be this minusing off this 56 out of 993. And the reason for that is because these 56 people are getting counted both here and here. They're getting counted twice, and we only want them to be counted once, so we're going to have to subtract one off. All right, so let's go back here, and we're going to just do the math on our calculator. If I go ahead and I put my calculator back up, and I take 330 plus 146, and then subtract off that 56 that gets counted twice, we will get 420 out of a possible 993. And in decimal form, that is going to equal divided by 993 equals 0.423. So it looks like 0.2, approximately 42% of the time, either the pedestrian or the driver were intoxicated. So that's the actual formula. Now, in a problem like this, where you actually have let me close this here, where you actually have a table drawn so nicely like this, we can actually see from this table, there's a little way to do this, which I like, but you have to have a table like this. That's why going through the formula is also important. But if we're asked to find the probability that the pedestrian was intoxicated or the driver was intoxicated, so the other way we can do this is, where are the intoxicated pedestrians? There are these people right here. These are the intoxicated pedestrians. And these people here, where are the intoxicated drivers? They are here. Use a different color here. These are our intoxicated drivers. And now you can see why when we did it before in the formula and we added up the 56 and the 74 plus the 56 and the 90, it's that 56 that gets counted twice, and that's why we had to subtract it off. However, if we do this method, what we can do is, because it's right there for us, we can just add the three numbers that are circled. We have the 56 plus the 274 plus the 90. And those together, you will see, if you add them up, the 56 plus the 274 plus the 90 equals 420, which is just what we had when we did it before. 420 out of a possible 993. Same result. So just a little shortcut when you're given a nice table like that. You can see, oops, it's written over, but you can see down here that it is the same result, whether you use the formula or you use the table method. So give it a try and roll.